So in this video, let us look at parallelograms which are on the same base and between the same two parallel lines. And what we will try and prove is that these such parallelograms have the same area. So here we have drawn two parallelograms ABCD and ABEF, and what we are trying to prove is that these two parallelograms have the same area. Now you only see two parallelograms. There can be any number of parallelograms which are on the same base and between the same parallel lines, and they will always have the same area. So to achieve this proof, what we have to do is the area ABCD, we can write area ABCD as the area ABED. So the area ABCD is this figure, this trapezoidal figure plus this triangle. So ABED plus the triangle BCE, and the area ABEF. The area ABEF is the other parallelogram, is equal to the same trapezoid plus the triangle ADF. Yeah, so ABED plus triangle ADF plus triangle ADF. So in effect, if we can prove that the area of triangle area of these two triangles are equal, then we will prove that these two parallelograms that we have drawn have the same area. So to prove that these triangles have equal area, we have to prove that they are congruent. So we have to prove that triangle BCE is congruent to triangle ADF. So notice that in this figure, the side AD is equal to the side BC, because they are the opposite sides of a parallelogram and they will be equal in length. Similarly, the side AF is equal to the side BE. Why? Again, they are the opposite sides of a parallelogram and hence they will be equal in length. And finally, notice that these two angles, let's call this angle 1 and call this angle 2. These two angles are equal. How are these two angles equal? Yes. So to do that, notice this entire angle. Notice this entire angle. This entire angle. Let's call it angle A. And this entire angle, let's call it angle B. Yeah. So notice that these are the corresponding angles of two parallel lines. So these are the two parallel lines, and this is the transversal line going across these parallel lines, and these are the two corresponding angles. So they will obviously be equal. So angle A is equal to angle B. Yeah. Similarly, notice these two angles. Yeah. Let's call them small a and small b. Let's call them small a and small b. Notice again that these two angles will be equal. Why? Because these are the two parallel lines and this is the transversal line and they are the corresponding angles. So they will be equal. So therefore, we are saying that angle A, small a, is equal to angle small b. Right? Now let's subtract these two equalities. So angle capital A minus angle small a is equal to angle capital B minus angle small b, which is nothing but angle 1, and this is angle 2. So we have proved that angle 1 is equal to angle 2, and we have all the elements in place to apply the side angle side rule, side angle side rule, side angle side, which on these two triangles to show that they are congruent. So these two triangles are congruent. So triangle ADF is congruent to triangle BCE, and this then goes back here, and this then helps us achieve the fact that the area of the area of the parallelogram ABCD is equal to ABEF.